Okay, we're in section 7 now, and section 7 is the material in integer exponents. Just a brief overview. We'll discuss what an integer exponent is, the meaning of it, and then we'll talk about some rules associated with it. All right, it's a good idea to pay attention to what's being presented to you. Although you may not have a full appreciation of what's being said, hopefully when we start doing examples, that more of this stuff will become understood. All right, it's not going to be a complete picture though, but it's probably enough to get through it. All right, so when I go through the basic rules, I'm hoping you have some appreciation of what's being presented to you. All right, we'll also briefly talk about scientific notation, but again, I want to be honest with you, I don't see it on exams, but it should be in this section of the notes. And furthermore, if you're taking any courses at Essex, like physics or chemistry, you'll certainly see scientific notation. And your calculator also uses scientific notation to express really large and really small numbers, and you should be aware of that. All right. And we'll talk about that. All right. We'll also go through some examples for you. All right. First up, lecture. I know it's dry, tedious, but we need to get through the material. Okay. Let me switch over to a whiteboard now. All right, so we're going to talk about this business over here. And my goal over here is to at least have some comprehension of what's being said. All right. So, so I'm writing this stuff down over here. My emphasis is understanding what I can understand. I mean, maybe I can't understand everything at this point, but it's what I can understand. So I'll just go through one thing at a time. And the first thing I think I can understand is whoops, sorry about that. I think I can understand this thing over here. And I want to tell you what it means to me. It means one factor of X. All right, that's what that means. Now, what does X squared mean? It means there's two factors of X. What does X cubed mean? It means there's three factors of X. And I have a pretty good understanding of that, and you should as well. Something you've been doing a very long time. Four factors of X. Now, if I wrote this one down over here, what is it saying? Well, I can't write down n factors, but I can tell you there's n factors of X. Now, the problem with this is this. If I write down like, X to the 10, I would hate to see you do this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I would hate to see you do that. I really would. However, you could do it. That's what it means. It means there's 10 factors of X. Let me erase that. Now I want to they put something interesting over here. A little disturbing, actually. And I'll put up, they put a coefficient of 1 on every single one. Now I kind of knew that. I knew there was like that coefficient of 1 in the variable. Now, so why would they do that? So I can understand the next one down, this one over here. What does X to the 0 mean? It means there's no X's there. None whatsoever. What's the coefficient though? It's always going to be 1. All right, let's go backwards. I know it's difficult. And I want to tell you what this means. This means there's one factor of X in the bottom. When I say that's a fraction now, right? What does X minus 2 mean? There's two factors of X in the bottom. What does X minus 3 mean? There's three factors of X in the bottom. What does X minus 4 mean? There's four factors of X in the bottom. What's X to the minus n mean? Well, more difficult. There's n factor of X in the bottom. What's the coefficient? Every single time, it's still going to be 1. I guess you get the idea, right? All right. If you can understand this, you pretty much have this section covered. However, what happens to a large number of students is they get to a rule-based system and they have a real tough time understanding rules. But you need to understand this first. This needs to be understood. You need to understand this. Every single one of these things that we write down, you need to understand that. Every single one. All right. We go to the next page and we're going to talk about basic rules. Right? Basic rules. I don't want to look at the boxes yet. So let's take a look at one at a time. What does x to the 0 mean? Well, like we discussed prior, it means there's no factors of x. By the way, they go on to say x can't be 0. Let's not worry about it. What does this one over here mean? And this is where a lot of students, they start to think that this one and this one are the same one. I want to go through with you though, and I'd rather you think though than read a rule. So I'm going to say over here that if I had x squared times x cubed, I would need to be able to think through that. And what does x squared mean? It means x times x. What does x cubed mean? X times x times x. Well, if you were to count that up, let's do it right now. There's 1, 2, 3, 4, 5. There's 5 factors of x. Now, someone's going to say, hey, you just add the exponents together. And it's true, I did. 2 factors followed by 3 factors is 5 factors. That's the only thing this rule over here is saying. Now, by the way, I say you should think about this. You need to reason through that. Let's do the next one. As I put this one down, it's going to be x. Now let's put down x cubed squared. I'm still going to write it down. What does it mean? Well, inside the parentheses means you have 3 factors of x. And then what do? I put it down twice. Let's count it up. 1, 2, 3, 4, 5, 6. There's 6 factors. I'll write that down. And I realize somebody says, well, they could do that by multiplication. And you're right. X 3 times 2. Get x to the 6. That's the only thing this rule is saying. My claim over here is please think. I'll tell you why. A lot of people see these things as if they're the same thing. They are not the same thing. All right. The ones that follow over here, I'm going to say pretty straightforward, not so straightforward. Let's take a look at it. X4 over x cubed. X times x times x times x. X times x times x. Well, I'm going to do some cancellations over here. I'll point out what I mean by that. If I saw this thing, it's like saying this over here, x over x, x over x, x over x. Then I got this last guy over here, which is x over 1. Let's just reduce to 1, 1, 1. You're left with x. Now let me look at that and say, which, you know, I could have done that by using a rule, and I'm not saying you couldn't have. What's it going to be? X. Well, there's 4 factors minus 3 factors. How many factors would you have? 1 factor, which we know to be x. All right. So I'm going to say this rule over here. Whoops, sorry about that. You need to think. All right. I'm going to say the next one up, kind of straightforward. Okay, I got 3 in boxes. These are the ones I am going to concentrate on in the notes. The other ones I can think about, and I'm going to think through them each one. After a while, though, I think enough times I develop the rules myself, and that's so important. You can do that. Only if you're willing to think, though. So I'm going to claim these guys over here are really, really important. But I want to tell you why they're important. Negative exponents are troublesome. So what I want to write down is the direction I want to go in. If you see x to the minus n, whoops, you will immediately write this down as, I'm sorry, that's an n, as 1 over x to the n. Notice I got the arrow down that direction. What's the arrow, the direction of the arrow? The arrow. Get rid of the negative power. Put that in that direction. If you see this one, you are immediately to write down this one instead. Now I'm going to put this as a fraction, and this is a fraction. All right, so x to the minus n means x to the, in the bottom means x to the n on top. X to the minus n on top means x to the n in the bottom. Let me put the arrow down over here. All right. It's important, you know, these arrows go in a direction. What's a direction? We're looking at a negative exponent. Whoops. I keep doing, sorry. We're seeing a negative exponent or as a positive. We see a negative or as a positive. Let's do the last one. All right. If you see we were to immediately write down this instead. What's that? It's a reciprocal. What's direction you want to go in? This direction. Here comes the problem. And again, I want to say this over and over again. You're going to see a negative power. Your goal is to write down a positive power. This over here is going to require a lot of thinking. And you need to spend time doing that. So I'm going to claim when I do the problems, I notice a lot of rules. Right now we listed 9 rules. There's a lot of rules. What am I claiming though? My claim is, although there's a lot of rules, I only got 3 boxed rules. Only 3. 3 are boxed. And for the most part, you need to understand 1 through 6 as a conceptual problem. 7, 8, and 9 over time will sink in. All right. We are going to be very careful when we do this. Here's the trouble though. Negative exponents need to be looked at and taken care of quickly. My goal here is one thing at a time. All right, let's go to scientific notation next. In dealing with very large or very small numbers, we like to use scientific notation. We do. We like it. Now, by the way, if you're bad at arithmetic, scientific notation is not going to help. If you're proficient at arithmetic, scientific notation will help in computation. I will say this, though, your calculator can also do computation. All right. So I'm going to say scientific notation is an aid in doing arithmetic. It's computational. But more importantly, it's an aid in reading. Because I'll be honest with you, if you give me a really large number, a large number of zeros in it, I'd have a tough time understanding it because I'd have to count all those zeros up to understand it. That's why we want to do the scientific notation. Now, what is it? There's a variance on it. As far as I'm concerned, I want to stick with this variance over here. So a number written in scientific notation, I'm reading this to you, when it's expressed as a number between 1 and 10 multiplied by a power of 10. We'll do an example. For example, a large number like this one over here. Well, I'm going to look at this number. I'll write it down for you. It's 20, whoops, I keep doing that. 23 million. All right, I'm going to write this down as 2.3 times 10. Well, 2.3 times 10 is 23. So what I want to claim over here, if I'm doing that, I really need to count places now. And I don't like counting either. Let's do it. 1, 2, 3, 4, 5, 6, 7. So it's going to be 10 to the 7th. Someone says, what's 10 to the 7th? I'll write it down for you. And if you did that, you would get 23 million. We prefer the look of this one up here. It's so easy for us to read that. All right. So I want to point out that's given in the notes. It's right over here. This also works for really small numbers. So for example, if I saw this really small number over here, I want to do the same thing. And I'll put this down for you. I notice this number's over here, like the other one had commas in it. You notice this one has little tiny spaces in it, right over there, space there. You see that, right? All right, let me write this down for you. 0, 1, 2, 3. They're polite. They leave a little space there. 1, 2, 3. They're polite. They leave a little space there. 0, 0, 2. They leave a little space there. 3, 5. all right? So what they're going to do is they're going to look for a number 1 and 10. It looks like that. And I'm going to say 2.35. Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9. So let's write that down. Times 10, but we want in the other direction, negative direction, minus 9. All right. Now, what does that mean? Well, if I were to write that down, that would be 2.35 over 10. I put this over here. It's always nasty with no zero down, but that's the number they gave us. This we prefer. Let me show you in notes. Right over here. Oh, I did it again. Okay. Let me repeat this. If you're bad at arithmetic, this is going to be of no assistance whatsoever. It'll make it worse for you. All right. My goal over here, though, is if you're proficient in arithmetic, this should make computation much, much easier to deal with. Let me go to the next page. And we'll look at an example of what they're claiming over here makes this a much easier computational problem. Now, I'll be honest with you, if I had to do this computation without using scientific notation, I would go right to a calculator. And by the way, I'm not opposed to it. So I'm going to write that down. You could use a calculator. I want to point out if you did a calculator, I still have trouble. And if you did a calculator, I want to point out a calculator. If you were to type this in a calculator, I really don't want to type it in, but it would look like this over here. I'll put this in black for you. 5, 0, 1, 2, 3, 1, 2, 3. I would use the multiplication symbol. Then I type in 0.000, 000, 000, 000. Yep, you can type it in. 6. And then what would I do? I'm even losing track of it. I would divide. That's a symbol of division on a calculator. That 20,000 cubed. I'll put that over there. I can definitely type that in. The problem a lot of students have when they see this on their calculator is going to say, oh, I can do that computation. And it's going to write this over here. This is where something to look at this. I have no idea what that means. What this means is 3.75 times 10 to the minus 15. And you can try it on your calculator if you like. I don't mind doing your calculator. Make sure you understand the meaning of that. All right. So let's go through the work, which looks pretty nasty. And I'll write this over here. I'll go one step at a time. So I'm take that first thing over here, the 50, right? So I'm going to say 5 times 10. I'm going to start counting for you. 3, 6, 7. Now let's do the other one. It's 6 times 10. Got to do some more counting. 3, 6, 9, 10, minus 10. What in that direction, right? Let's go to the bottom. What's that going to be? 2 times 10. Let's count it up. 3, 4. All right, I'm going to do the top now. I know it's tough. And what would you get there? I'm going to commute things around. What do I mean by that? I'm looking at this thing. I'm saying 5 times 6 is 30. That's pretty simple. And I see those 10s. And how many are there? There's 7 of them, followed by minus 10 of them. I know it's tough. There's going to be minus 3 of them. Well, addition of exponent. But I'm not saying you're there yet. And if you're really bad at arithmetic, this is not going to be helpful either. The bottom, I'm going to cube it. So what are we going to cube that? Well, 2 cubed is 2 times 2 times 2, which is 8. times 10. Well, it's 10,4 times 10,4 times 10,4. That's going to be 1012. This is getting kind of nasty, right? Let's keep going. I'm kind of looking at it. And I'm going to take this negative exponent on top. And I'm going to bring it to the bottom, like I said. And what's that going to be? 10 to the 15. Oh boy, I got 30 divided by 8. Let me write that down for you. 30 divided by 8 is 15 quarters, right? 15 quarters, right? Let's do this. 4 into 15. That goes in 3, right? That would give you 12. 3, 0. 7, that's point now, right? 28. 2, 0, that's 5. So it's 3.75. Wow. What do you get over here? 3.75 times 10 to the minus 15. I realize some students would say it's way too much work. I'll use my calculator instead. We're not opposed. I'm not opposed anyway. But make sure you know when your calculator does that arithmetic, when it does that arithmetic, it's going to report back this number here. Make sure you know that number on your calculator is actually this number here, the number we just did by hand. Calculators are certainly faster. What's the problem? Typing all this business into your calculator. Can it be done? Of course it can. You can use your cell phone to do it. All right. So I'm going to say we're done with that section. What section are we done with? We're done the section on the there's integer exponents, and we'll start doing examples. Right. Examples come up next, and we'll do the examples next. All right. Thanks for listening. I know this is tough too, but we want to push it forward, and hopefully that you can move forward smoothly. And we're going to do examples next.